In this problem, we have a ladder. As per the text here, find the length of the shortest ladder. This is the ladder. The shortest length of this ladder that can be this way here. I mean, that will reach from the ground over the wall, 8 feet high. This is the wall, to the side of a building 1 foot behind the wall. So the ladder should reach here. In this case, the total length of the ladder is L1 up to here, plus L2. And this is what we are required to find. So we have to have a strategy here. What we can do is, we have to understand the question. The question is to find the shortest. Shortest calls for minima. That means we need to calculate the first derivative of these lengths when we find its equation. And then the tools needed to do that, we of course need the formulas and all that. And the ways to solve the problem, we will use 2 ways to solve these problems. We will go completely trigonometry and we will go completely algebra. We'll start with algebra. We'll solve it in another video. We will solve it using trigonometry. And we will use additional tools to proof check what we did. Alright? So, first thing to do here is to find our length. It is already given to us that L is equal to L1 plus L2. The idea here is to find L1 and L2. But if we notice here this triangle, the small triangle and the big outside triangle, they are all similar. So if you have done some geometry similarities, this is a no-brainer. Anyway, we also know that this is there is a right angle here. So this is hypotenuse for this one, and this is a hypotenuse for that one. We just know that this is one foot, and we also know that we can call this one a y to help us calculate this. So quickly, we can say that L is equal, we know L1 squared is equal to x squared plus 8 squared. This 8 squared, this is 8. Okay? So is equal to x squared plus 64. Meaning that L1 is equal to square root. We let go the negative part because this is length, has to be positive. Square root of x squared plus 64. The same way we can find L2, but in L2 we can say that L2 squared is equal to 1 squared plus y squared, and it is equal to 1 plus y squared. So L2 is equal to square root of 1 plus y squared. But in this problem we don't know y. We have to find y. We use our similarity knowledge. We know that this one over that one is equal to that one over that one is equal to that one over that one, the big one over the small one here. Okay, so we can say that x over 1 is equal to 8 over y, meaning that y is equal to 8 over x. Okay, so now we know how the value of y, we replace it here. That means that L2 is equal to square root of 1 plus 8 over x all squared. So L2 is equal to square root, write it nice, square root of 1 plus 64 over x squared. Now that comes to our final lengths. The lengths we are looking for L. We say that L is equal to L1 plus L2. We add them up. So L is equal to L1, we found L1 square root of x squared plus 64 plus L2 plus square root of 1 plus 64 over x squared. So this is what we are looking for. In our next video, what we have to do is to find the derivative of this function, and once we find the derivative, then we go ahead and replace x by its value in the equation here. So that's what we are going to look at the next video.